Thank you very much for attending this webinar on PathPilot. I've got a number of slides for you here, a couple of YouTube videos, and a little bit of a screen share to give you a preview of the PathPilot interface. I'll try to keep that part to about 30 minutes, and then we'll have room for Q&A. The last couple of webinars that we've done, there's been a lot of Q&A, so if you have questions, this is a good place to ask them. Before we start, a few introductions. My name's Daniel Rogie. I'm the controls engineer here with Tormach. I do motors and drives and software. Jason Penn is our senior embedded systems engineer. He does a lot of the firmware for our products. He's also done a lot of the software development for the PathPilot interface. John Prentice is over in England. He's actually the first hire at Tormach. He's a retired university professor, consults with us on a number of different subjects, but he's been instrumental in the design and in writing some of the code for the interface. Dan Montenegro, I mentioned before, is our photographer, but he also does graphic design, and he did a lot of the artwork that you'll see on the PathPilot control. Robert Yellen from ZBot. Some of you, if you have an ATC, you may know Bob. He builds our ATCs. He was part of the design team on the ATC, and he's done a lot of the software. He did the Mach 3 integration for the ATC, and he's also done the integration to PathPilot for the Tormach ATC. Kirk Wallace is a consultant from the Wallace Company. He did a lot of the conversation code and many other parts of the user interface, including some of the beautiful graphics that you see on the lathe conversational screens. Rob Ellenberg works for Carbide Labs. He did a lot of the trajectory planner rewrite, and I'll discuss that in a bit. And then he's done some other improvements for us as well. And then Wade Wendorf, if you're part of the Tormach users group up in Minneapolis, you might recognize Wade. He is doing quality assurance and regression testing, stuff like that for us. So those are the folks involved from Tormach. And then we'll jump into it here. Very soon we're going to be switching machine control software from our Windows Mach 3 machine control computer to PathPilot. That switch is going to occur early April, meaning new machines that we send out will come with PathPilot and will not include Windows or Mach 3. So the remainder of this presentation, I'll discuss what PathPilot is, why you might want to switch to PathPilot, why we decided to do this work, and that will include some of the project's history and the project's roots in the open source community. We'll also talk briefly about why you might not want to switch. This isn't going to be right for everybody. And then lastly, we'll talk about how you get it if you already have a Tormach machine. So what is PathPilot? Simply put, PathPilot is a purpose-built, dedicated machine control computer. It includes a true real-time operating system, which greatly increases the reliability. But it gives you the performance of like a dedicated motion controller. Imagine a FANUC or a Siemens motion controller, and it does it all at the economy of a personal computer. So we're leveraging consumer electronics cost and marrying it with real-time reliability and PLC-style performance. Why should you switch? I suppose that's why you're all here at the webinar, is to find out why you might do this as an improvement. So I've got 5 bullet points here, and we'll go over them in detail in the next slides. But here's my list of reasons why you should switch. It's running on a real-time operating system, which improves the reliability. We'll talk about that in a moment. We have hardware-based signal generation instead of software stepping, and if you don't know what that means, we'll be discussing it in a bit. We've made improvements to the G-code interpreter and improvements to the trajectory planner. And then we took the opportunity while we were doing this to completely redesign the graphical user interface to make it easier to use and easier to learn, both trying to help out our customers and also to hopefully reduce some of the confusion over our old interface that was causing some support call problems. And then I'll add one point down here. another reason why you should switch is that we're now maintaining the software actively. We're not relying on a third party to support it. And I'll cover that kind of last in the presentation, but I think it's a very important point. So I mentioned it has a real-time operating system. What do I mean by that? In a real-time operating system, you can prioritize certain tasks over others. So for instance, if you're controlling a machine tool, you want motion control to be the highest priority task. You don't want other things like virus protection or screensavers or network activity to take priority. And it's not that Windows doesn't offer real-time operating systems, but our old control software didn't work with them. It was really a Windows XP or Windows 7 limited software. And then also real-time Windows like Perco runs on a real-time Windows control, but it's quite expensive. Whereas in Linux, there are free real-time operating systems available. And so in the PathPilot is based on Linux, and it's running on a real-time Linux kernel. Motion control tasks take priority over things like plugging in your flash drive or unplugging your keyboard. Motion control takes priority over screen refresh. So moving the toolpath display around while you're running G-code is now possible without problems. Motion control takes priority over network activity or a whole raft of other things like sound manager, things like that. And one of the reasons why this is important, we, for a long time, have been sending out a document called Best Practices for a Mach 3 controller, and a lot of that was related to trying to teach people to not really do anything else with the computer while the control software was running a G-code program. And that's because the control software wasn't able to prioritize motion control over other non-real-time tasks. With PathPilot, that's changed. And something that has been especially problematic for us is USB events, like unplugging your flash drive, in our old software could cause motion control problems. And unfortunately, with newer computer architecture, computers made in the last couple of years, just a bad noisy power supply to the computer can cause spurious USB enumeration events. So you know, if anyone's gotten a service bulletin on electrical noise and USB issues, that's something we've been struggling with for a while with our old Windows-based system, and it's a thing of the past. PathPilot handles this perfectly. I was going to say much better, but it's unplugging a USB stick while running G-code has no bad effects with PathPilot, so that's a big win. So I mentioned hardware signal generation. I said something about software stepping. If you can imagine a computer doing software stepping every 25 thousandths of a second is trying to decide whether or not it should take a step. And that's called the interrupt frequency. And the computer has a pretty hard time doing that reliably. You get a fair amount of jitter. Got here, 6,000 nanoseconds. That's actually a pretty good figure. Some computers are much worse. It's one of the reasons that we sell a dedicated machine control computer, is that not all computer hardware will perform even as good as that jitter figure you see. But with PathPilot, we've offloaded that signal generation to a PCI card with an FPGA chip on it. And the result is the interrupt frequency is much, much higher. Jitter is order of magnitudes lower. And what that means for you is smoother, more reliable motion. You can envision, you actually hear it in the motors. It sounds different when you're running a mill under PathPilot. And Greg likes to make an analogy here to the automotive industry. If there are any gearheads out there, you can imagine the task of generating steps as analogous to the task of creating sparks for your engine to fire. And the idea here is that if you had to have your computer making those sparks, that would be the old control solution. Whereas if the computer were managing cruise control and you had an engine control unit dealing with the spark, the computer's task is a lot easier, right? Computer doing cruise control has a way easier task than a computer trying to time all those sparks. And you can also imagine the effect that an engine might have if the sparks had some timing jitter to it. You know, an out-of-tune engine runs rough. It might get you from point A to point B, but it's not ideal. And that's the situation we have here, if that analogy makes sense. As I mentioned earlier, we made some improvements to the interpreter. So cutter compensation now works. It works with subroutines. Subroutines also have conditional statements, so you can use if, then, do while loops, all sorts of things. If you guys are subroutine happy people, this is a much more flexible system than our old software. And then this is something that I think is really important. We get warnings on invalid G code. So to back up a little bit, our old control software often would accept bad G code and not tell the user about it. And sometimes this was of little consequence. And I'll give you an example. G83 can drilling cycle, the FANUC G code standard doesn't have a p-value associated with a G83 cycle, but Mach 3 was happy to accept a p-value on the G83 line. If you program G83 with a P word and your control software doesn't warn you that that's invalid, who cares? Maybe you thought that it would dwell at the bottom of the cycle and it didn't. You know, that's not that big of a deal. But I, for one, would like to be told, you know, if I have a p-value on the line, I'd like to know that that wasn't going to be respected. With Mach 3, it would happily just chug through the code and wouldn't tell you anything, and just would throw out the p-value. And that's of low consequence, right? I mean, I think we can all agree, it's not ideal, but if that's the way it works, so be it. But that's not the only bad code that our old software would accept. And I've got a photo here actually from a customer. And what we have here is an example where the CAM software was spitting out bad arc radius values. So these are I, J, or K values for which G2 move, the start and end point. There was no radius that you could draw with the center of curvature and the start and end point that would match that up. And it was bad CAM. It was a fault of the post processor, but our old control software didn't flag it. And so our customers were machining these parts and kept saying, why is there this giant defect in the part? And we worked back and forth with them, finally figured it out, actually by loading it into a beta version of PathPilot. Then in fact, the G code was invalid. And you know, this is a big headache for people. If they have bad code that they're trying to feed in the machine, you really want to know if it's not going to run correctly before you go and damage the part. So that's a big improvement with PathPilot. And if you happen to be the customer whose part that was, and you're in the webinar, maybe you could chime in. I'm sure that was a frustrating experience for you. So other reasons to switch, we've made big improvements to the trajectory planner. I think a lot of you are going to like this. It's much more responsive. So that means if you hit pause, it pauses instantly. Pause and stop are now instantaneous. In our old software, you press the pause key and it would take 2 seconds to pause, which by that time you've broken the end mill. And we actually had to remove the stop button from our old software because stop was an uncommanded no acceleration or deceleration values were respected, so you get loss of position if you're going quickly and hit the stop button in our old software. The new software, PathPilot, works perfectly in that respect. The overrides are instantaneous. We also made some improvements in terms of the ability of the trajectory planner to interpret the program, so we get faster program execution. And I've got a little video I'll show you momentarily on that. And then last, in our old software, you could do exact stop, which is G61, or you could do constant velocity, G64. So you either go slow and accurate, or you could go fast, and who knows what your inaccuracy is going to be. With this software, you can actually set that up with a p-value on the line. So if you want to go fast, wide out for mold making or something like that, you can say, I don't want my path to deviate by more than 1,000 or more than 2,000. That p-value allows you to tune that. So let me just show you here the program execution improvements we've made there. I'm going to show you a video that has, first it shows PathPilot, and it'll be doing a spiral, which is a really difficult, it's a challenging task for a trajectory planner. You have a lot of small line segments that come together as the spiral widens up. And then we'll show the same code running under Mach 3. So hang on just a moment. So you can see there in that second video how a little bit into the spiral it started shuddering and taking longer. Actually, the machine was shaking when it was doing that, and then finally it's able to add the line segments as they get larger towards the end there. But that's one of the improvements we've made in terms of faster program execution. Coming towards the last bit of why you should switch here. User interface has been completely redesigned. Our old screens, you know, the simple run, the comp run, the MTI screen, the toolpath screen, it was basically the same controls in different sizes in different layouts, not exactly adhering to kind of rules of good interface design. We tried with PathPilot to really simplify things, to make it cleaner. The buttons are all fairly large, very touchscreen friendly. We also were able to roll some of the external programs that we needed right into the software interface here. So if you've used PCNC config to change your probe polarity, maybe you have a passive probe but an active tool setter, you'd actually have to shut down the control software, open up PCNC config, change the accessory input polarity, close PCNC config, open up the control software again. No longer do you have to do that. It's just a single button on the settings screen. You click and you can change from the passive probe to the tool setter just like that. Similarly, tool assistant program, the USB height gauge, no need to open a separate program. Just now you click that little USB button and the tool height is transferred right into the tool table in the GUI. Conversational screens are now written and supported by Tormach, which I think is a big improvement. Our old wizards, you know, we included them in the software, but we didn't take any responsibility for them. We didn't debug them with people. At least one of them was written in French. But with PathPilot, this is all stuff that we've designed. If we find bugs in them, we'll certainly fix them. Some of the probing stuff, this is a good example of how we've simplified things. In our old software, finding the center of a circular boss involved putting an approximate diameter in, setting a clear plane, all that stuff. With this, you just have one button, and you can see here in the video I'm about to show, the circular one, it taps 3 times, gets an approximate diameter, and then it goes around to do an accurate finish touch on all 4 edges. So let's see here what we have. So that's an example of how we've tried to simplify things by, you know, removing the number of different input fields and labels you might have to do a simple task like probing the circular box. And probing includes similar stuff that you had before, but now we've included slot center finding, and adjustment and setup is all handled in the interface as well. Improved toolpath display, which is I think a big improvement. We've got program extents, so you can see here down in red, we have lines that show you exactly how far the program will go. Also, machinable area, the limits of travel is displayed. You've got some grid lines, and I'll show you that in a second when we go through the user interface, but you can select different increments of grid to show, which is nice if you're trying to verify that what you think you're about to machine is actually what you're about to machine. And then you've got the four views, right, top, front, and ortho. And as I mentioned before, because we're on a real-time operating system, you can actually move and rotate the toolpath while you're machining the part, which is really nice. You don't have to worry. You don't have to put on the kid gloves and think, oh, I shouldn't touch anything on the screen while the code is running. That's no longer the case. That real-time operating system is really helpful in that respect. So let me do a quick overview here of the screen. I'm going to share my screen with you. So what we've done is divided the screen roughly into two halves. The top half has a number of different tabs that allow you to perform different tasks. And the bottom half is all the persistent controls. These are here no matter what you're doing up in the top half of the screen. So this group here, the bottom left third of the screen, cycle start, single block, these are all program controls, things you might do while running a G-code program. Most CNC operators, including people that have used Mach 3 before, most of you will be familiar with these. The middle lower group here is the position status group. So we've got work offset coordinates, DROs. You can enter and change work offsets. You can zero them. Distance to go labels in this column, and then reference buttons, and then a status line of active G codes. On the right lower third of the screen here, we have manual controls. That's step increment here, jog percentage, spindle forward and reverse, and an RPM DRO, feed rate DRO, spindle range button, tool change, and go to tool change position button. So that's the persistent controls. Up along the top, fairly standard stuff. We've got the G-code listing. We've got a drop down of recent files here. So you see you can scroll. One thing people always asked us was, could we make the G-code display bigger? Sure, you just double click on it and it gets larger and the toolpath gets smaller. Double click to go back. MDI line here. Here's the toolpath display I mentioned before. We can change the grid sizes. You can also take a look at the views. Let's see, top view here, we see the program extent. So this program goes from about ½ an inch tall to -10 thou, and in X, we're looking at total travel of 2.140. So I think that's fairly handy. File screen for moving G-code files from a USB stick. You get a little file preview here. Changes as you pick different files. Settings screen, here's the, if you want to go from the digitizing probe to the passive probe, it's a single button click, no more PCNC config. For touch screens, we've got a soft keyboard that allows you to, bring up a little numeric keypad, or if you're an MDI, brings up a whole QWERTY keypad. So things like that. Scanner is supported. Pretty much everything that you had in our old software is supported. Scanner is still in kind of an alpha phase, but we are committed to getting that going correctly. Offset screen, greatly simplified. This should be a lot easier for folks. We've got the tool table here. As I mentioned before, the height gauge plugs right in, and you can use the height gauge to go ahead and set values. Work offsets here. Conversational screens are quite nice. We've got facing, profile, both let's see, Pocket does both circular and rectangular pocket, drilling and tapping. So, and by the way, G84 tapping cycle is supported in PathPilot, where it was for a tension compression tapping head, where it wasn't in our previous control software. We've got thread milling here, and then engraving. You enter these values, post a file. It's saying this thing already exists. I'll go ahead and override it, and there you go. It's pretty quick, straightforward stuff to do. So it's a tour of the user interface. Let's see, what did I miss? Oh, if you have an ATC, this will look very familiar, very similar to our old software. Things like injection molder included right here. So yeah, I can go back to the screen share later on in the presentation if people have specific questions. Oh, and then a few last comments about the user interface. If you have a duality lathe, switching to duality gets you the exact same user interface as the Slant Pro, which is great because we spend a lot of time working on conversational routines for the Slant Pro lathe. So if you have duality, this just comes along for the ride. You get the same interface as the Slant Pro with all the great conversational stuff. And yeah, because we're managing the software actively now and not reliable on a third party, future development is open to suggestions. We're thinking about doing some tutorials, embedding them in. We've already had some feature requests from the beta program that we feel are pretty good. We're going to be working on them. The sky's the limit here. So that's why you should switch, why you might want to switch. I do want to talk a little bit about why we decided to switch. And I'll also cover a little bit of the history of this project. So why did we switch? Mach 3, especially when we started selling machines, was best in class. I mean, we could not have sold milling machines if we were putting a FANUC control in them because it would have tripled the price of the machine. And Mach 3 was a great solution for a long time because it allowed people to use our machines at the price that they've been able to purchase our machines for. It really has helped the mission of Tormach, which we take very seriously, enabling people's ideas, helping people make things. That was something that our previous control software fulfilled for us for a long time. That said, it has always had some serious limitations, and high on that list is the frustration that our users have had with the idiosyncrasies of Windows and Mach 3. And I want to be clear, much of that is the fact that it's a Windows-based non-real-time operating system. Things like the USB enumeration event being caused by electrical noise, causing motion control problems. That is a Windows problem that we've done our best to work around with the Windows system, but it's just a fundamental limitation of a non-real-time operating system. So moving to PathPilot was a huge help for stuff like that. And then kind of secondly, Mach 3 wasn't really a viable candidate for the lathe. There were some critical flaws with the lathe. Constant surface speed and feed per rev would not work at the same time. We found bugs with threading that weren't going to be fixed, at least not in Mach 3, perhaps in Mach 4. But we felt like it just was a non-starter for lathe. So in working on the lathe software, we had completed about 75% of the work that we needed to do to create the mill interface under PathPilot. So I touched on this earlier in the presentation, but I want to emphasize it here. A huge reason to switch, one of the big reasons that we started the project, and a big reason I think for you to consider switching, is that we're no longer reliant on a third party to do software support. Previously, if we found a bug or if a customer reported a bug in our control software, we'd have to go back to our vendor, show them an example of the bug. There'd be a lot of back and forth. Maybe it would get fixed. If it did get fixed, it often got fixed in a much newer version that may have had some other bugs or features that we didn't want. It was a very time-consuming process, and sometimes we'd find fixing a bug would end up causing new bugs that we didn't want to, it's just a big risk. We're no longer beholden to an outside vendor for bug fixes. If you find a bug in PathPilot, and some of our beta customers have already been finding them, if you find a bug, we will fix it, and that's a huge improvement. I'm sure it's a huge improvement for you. It's a great improvement for me and for the other people that work here in tech support at Tormach. It's so nice to be able to help people when they call up with a problem, as opposed to just suggest a workaround. So that's great. And then another thing to point out, this software, PathPilot, is based on a number of other open source projects out there. The code base for PathPilot started at the National Institute of Standards and Technology, and then that code was taken by folks in the EMC2 project, now known as Linux CNC, and then also forked by MachineKit. These are open source projects to do CNC control, and they are very active. There are a number of very smart people doing development for both Linux CNC and MachineKit. And one of the benefits, I think, to Tormach customers is that when one of those very bright developers in, say, Linux CNC or MachineKit does some work, we're able to leverage that work and bring that to you at much less cost than if we were doing that work entirely ourselves. So I showed you that beautiful toolpath display with the program extents, and I want to be totally clear, that's not code that I wrote or that Jason wrote or that John or Ron wrote. That's code that came from these open source developers, and a lot of very bright people working on this software. And I think it represents a tremendous value to Tormach customers to be able to leverage that for you and bring it out to you at a much reduced cost than say you would if we had to write this from scratch. To that end, when we make improvements, we share these back with the community. We've actively given back the trajectory planner work, a lot of the G-code interpreter work. We've shared the entire source with the Linux CNC and MachineKit folks. So I think it's a win-win. It exposes more people to Linux CNC and to MachineKit. They get stuff that we're working on in a commercial setting, and we get to use some of the stuff that they work on in the open source setting. So that's a big benefit. As good as this is, and as much as I believe in it, there are definitely people who might not want to switch. So first off, if you like your current Windows Mach 3 control, and if you've got an older computer especially that perhaps runs it well, if you're happy with it, if it's not broken, don't fix it. If you're happy with what you have, I don't recommend jumping out, and especially during the beta period, I don't recommend going out and grabbing PathPilot. But if you've been frustrated with some of these other issues I've mentioned, then by all means, please do try it out. There are some downsides to PathPilot. For one, it's harder to customize. We've got, if you look at this screen, I've got, I can't remember what that thing on the right is. A customer sent us that. Some custom project that's going to be a lot harder to do with PathPilot. Mach 3 was fairly easy to customize. On the left here, we have a custom screen set by a customer that makes flutes. So stuff like that is nearly impossible to do in PathPilot. And then you also, perhaps you've got several operators who are already familiar with the old interface. There may be some cost for retraining them. So there are reasons why you might not want to switch. I think for the vast majority of people, switching is a good idea, and I would recommend it. But if you've got some customization that's going to be difficult to support, or if you're really happy with what you have, then I'd say wait till this matures. So how do I get it? Well, first off, if you bought your control computer in August of 2014 or later, you already have that hardware-based card installed. All you're going to need is an operating system DVD. If you purchased a control computer from us before August, you'll need a hardware upgrade kit and an install DVD. We've got those on the web. And then we have older computers that we sold here to test on back about 4 years, but we haven't tested on some of the oldest control computers we sold. We used to sell, for instance, Dell Optiplex computers. We don't have them. I don't know if it'll work. I don't know if the upgrade kit will work correctly. It may work, it may not. If you have your own control computer that you want to try putting this on, obviously we can't take tech support calls on every flavor of computer hardware ever made. So all we can say is if you have a controller made that you purchased from us and made in the past few years, if it's one of the ones listed on the website, we can help you get PathPilot up and installed on it. Cost says DVD is free, limited term. That limited term has expired. The DVD is $10, and the hardware kit, which includes the DVD, is between $95 and $115. It really depends on which. There are 2 types of PCI cards that go in there. It depends on which card you need. And there are instructions on the website. So before we open this up to Q&A, I've just wanted to stress a couple of points, and then I've got some thank yous to go out, and then we'll do Q&A. So PathPilot is an enormous step forward in both performance and reliability. It's a faster system in terms of its ability to run code. It's got a much better interpreter. It's much more reliable. And then second, and I can't stress this enough, we're now responsible for this. So if you find bugs, we will fix them. If you really want enhancements, please suggest them. We very well may write them in. So those are big steps forward for us, and I think it'll be real positive for you. So wanted to give some special thanks here to some developers in the open source communities of MachineKit and Linux CNC, Sam Sokolek, Michael Haberler, Charles Steinkühler, John Morris, Chris Radek, Sebastian Kuzminski, Jeff Epler, Andy Pugh, John Kucinich, the folks at NIST like Kent, Reed, and many others, Chris Morley, number of other people, very bright people involved in those open source projects. So thank you to you all.